Arfan's not here. Sanjeev. Sorry, Hassan. Hassan Aziz is here too. Great. I know, yes, you are. Hassan, Sanjeev, and Sebastian. Thank you. Jerwin. Thank you. Harshal. Dewu. William. Raymond. I saw you saying hello, so I know you're here. Bilgun. Not here. Zero. Oh, Zero's here. Gabriel, you should be here. It's your project. Hope. Okay, welcome as well. Aaron, or Samuel, sorry. Brian. Fee. Ifani. Not here. Hongwei is here. Sadat. Thank you. Ran. Michael McDowell. Trong. Honglin. Valerie. Okay, Asia. Hassan Safwan. Veronique. Thank you. And Carla. Okay. Shubham. James. I think I say her name. Yeah. Prem. Claudia. Kiefer. Ray Fung. Thank you. Hayden. And Lashui. Oh, Hayden is here. Okay, excellent. If I didn't call your name, let me know. Oh, you're here. Okay. Also, I do watch. So if you say you're here and then you leave, I take you off. Okay. That happened last week with somebody. Okay. So, all right. So group 8. Last but definitely not least, group 8. Are you guys ready? Okay, excellent. So what's going to happen, guys, is we're going to, finish the final group, and then it's going to be a work period, and I'm going to open up Teams like every time, okay? So get started. Good luck, guys. I'm going to go ahead and mute myself. You can get started.
Are you able to hear me?
Yes.
Okay, sweet. Hi, everyone. My name is Michael, and this is our presentation on steel versus concrete highway bridges. So lifestyle cost slide. For inspection, it is much easier to establish the structural state of a steel bridge in comparison to a concrete bridge, due to how visible the components are. Since steel can withstand the weather with a high performance, it allows the steel to have a long-term durability, and it will be cost-effective due to sustainability. You can easily see all the components in the picture for the steel bridge. Next slide. So for the cost, one of the biggest advantages of steel is the weight savings. This means the equipment is cheaper since the bridge pieces can be handled with lighter equipment. Steel bridges last longer than other types, which allows them to not be replaced as quickly. Steel components require less maintenance and inspections. Next slide. For the environmental effects, steel comes in handy when analyzed in an environment. It is highly adaptable to different environmental conditions. Since steel materials are often considerably light when compared to other materials, it reduces the amount of energy that is used during the delivery and construction process. Steel allows a longer span to be built, which assists with the weight to be spread across the area, rather than it being concentrated onto a small area. The rolled shapes and angles are 100% reclaimed steel from scrap, and the plates are about 75% recycled steel. Steel is the most environmentally friendly material used in bridge construction. This is a video about the old Highway 76 bridge demo. Is there a way to get sound on that video?
I'm not sure. I might have to reshare it. Just give me 1 second. Is there sound now?
No, it's okay. Basically, the video just talks about how the bridge costed 10.4 million to build, and then it no longer met the criteria for the standards nowadays, so they had to demolition the bridge. Next slide. So for the material qualities of steel, some of the materials are strength, toughness. Steel has a downside when it comes to toughness because, I'll cover that in a later slide. Ductility, weldability, and durability. The most used materials for bridges are carbon steel. This is the cheapest product structural-wise that's available. High-strength steel. It's more durable when adding different mixtures of steel, and it's usually more expensive and requires special welding techniques. Weathering steel. Its strength is high, is anti-corrosive, and has properties such as withstanding weathers for 100 years and over. Heat-treated carbon steels. It's the strongest available, and the exposure of heat results in it being high strength. For stainless steel, it is used in conditions crucial, such as safety, bearings, and guardrails. And this is the most expensive one, which means it's limited. Next slide. So for toughness, it is normal for materials to have imperfections. The most common imperfection in steel are the tiny cracks in the hardened material, which leads to brittleness. The Trapi V-notch impact test determines the toughness of steel. Depending on the grade of steel being used, there are certain acceptable levels of impact strength. For weldability, all structural steels are essentially weldable. However, welding involves locally melting the steel, which subsequently cools. According to the American Iron and Steel Institute, steel comes in 4 main groups based on the chemical compositions. Each group varies in carbon content and therefore possesses different weldabilities. The 4 groups are carbon steel, alloy steel, stainless, and tool. Some of the best metals for welding include low carbon mild steel, aluminum, stainless steel, and other metals. Next slide. So now it'll be Gabriel's turn to speak.
Hello, can you hear me?
Yep.
Okay. Hi, my name is Gabriel, and I'm going to keep talking about some other characteristics of the steel. Now is the turn of the corrosion. The main cause of the corrosion of the steel bridges is because the exposure that it has in the atmospheric conditions, the south spray exposures, and the industrial environment. And now how we prevent the corrosion? The method will be to implement it will be a barrier of coating of paint. Can you please change the slide? Well, another characteristic will be the aesthetics. Steel bridges are usually significant structures that have the power to add or detract from the landscape. Their beauty has more to do with overall design in terms of geometry, proportion, structural concept, and the integration with the site. And the last characteristic that I will mention will be the design needs. The steel can be bent and twisted to create any type of bridge. They can be formed into any shape from a simple straight line to a complex curve. The surface of steel may be detailed in complex way and painted in a full range of colors. Steel utility infrastructure can be attached under a bridge and hidden so it doesn't affect the design. Can you please change the slide? And now talking about the benefits. The benefit would be lightweight construction, the sustainability because they can recycle steel to create more. The attractive design, as we mentioned before, they can be bent and twisted so they can be formed into any shape and painted at any color. The faster construction because they can be joined together to create the structure that we are looking for, and much more. Can you please change the slide? Well, there is different type of bridges, such as box girder bridge. They are usually manufactured from prefabricated steel girders. This means that the girders are manufactured in a factory and transported to the location of the bridge, where they are fixed together. The steel girders of a bridge are fixed together usually with large nuts and bolts. Can you please change the slide? We also have the beam bridges, also known as a stringer bridge, are the simplest structural forms for bridges span supported by the abutment or pier at each end. And the truss bridges is a bridge whose load-bearing superstructure is composed of a truss, a structure of connected elements, usually forming triangular units. Can you please change slide? And we also have the arc bridges, also known as a half-throw arc bridge or a throw-type arc bridge. The base of an arc structure is below the deck, but the top rises above it. Like that, the deck is between the arc, and cables or beams that are in tension suspend the central part of the deck from the arc. Can you please change? And to finish, I'm going to talk about the delivery of the steels. For delivery, there's many options to transport and deliver the steels. They can be transported from boats to trailers. Once the steel is in the site, they can be lifted into place by cranes and bolted and welded together to complete the structure. Or they can just be slide or rolled to their final positions. Can you please change? Well, here is a video of how they build the bridges, they manipulate them, and how they install it. Can you play?
Guys, I think it might be the way you are sharing. Maybe try sharing the entire screen, not just the PowerPoint, because we can't hear anything.
I'm going to talk about concrete highway bridges. Concrete is a sustainable material because its primary raw material used to create a cement is a limestone, and the concrete is made even more sustainable by use of the fly ash, which is a recycled waste material from coal-fired power plant. It can reduce process new materials and limit pollution in transporting material to sites. Concrete is recyclable. For concrete project can reduce waste. When a bridge has reached end of the lifespan, the concrete can be recycled by crushing it and use it as fuel for roads. It can reduce the waste in landfills. The vast majority of bridges worldwide are constructed of structural concrete, and reinforced concrete often used in highway bridges. Concrete provides strength against compressive stress, and reinforcement provides stress against tensile stress. The average lifespan of bridge range is between 50 to 70 years. But however, poor concrete practice and low quality material can reduce those lifespan up to 10 years. But for any concrete bridge that well designed with maintenance, and the lifespan can be of around 100 years. One of the main factors in concrete technology is permeability. The ability of concrete to resist water and chemical migration. Migration of salts, chlorides, seawater, and other chemicals can cause cracking in concrete and will reduce the lifespan. Concrete must be impermeable to migration and provided with both physical and chemical durability. The ability of concrete is to resist environmental condition. It is a physical durability. For physical durability, like when a concrete cracks in physical way because there is a change in volume, for example, due to the temperature change. And here's some point need to consider for concrete durability. Is abrasion, freezing, and thawing, raining, and humidity. And for chemical durability, there's a ASR reaction and the chemicals and chlorides and steel. Here are the most benefit for concrete bridge is the function and elegance, durability, versatility, and speed and buildability, sustainability, economy, and maintainability, and also ease of construction. Here are the most common type of the concrete bridge. First, slab bridge is made composed of single or multiple spans. It's easy and simple. It's well suited for span up to 50 feet, but for any longer span, its continuity with abutment and piers can mobilize frame action. For eye girder, a simple beam bridge is a common use for moderate span. It is the most popular bridge type. It span up to 160 feet, and the common depths for eye girder was 20 inch, 36 inch, 45 inch, 54 inch, and 72 inches. And segmental bridge are popular when the construction site is restricted. They can be cast in place or precast, and can employ span by span or boneless in the cantilever construction. It perfectly suited for gradual and sharply curved alignment. The maximum span is greater than 300 feet, and the repetition of any short span is from 70 feet to 150 feet. Here's a video that shows highway bridge construction. Just 1 second, I think it's loading. Oops. Now, okay, there we go. It's a pretty long video. I'm gonna speed it faster. Yeah, and I'm gonna head over to Yvonne, can talk about the compression part.
Hi guys. So after listening about the steel and the concrete highway bridges, you guys may consider that steel was concrete material, which is better, right? So I will give you a brief comparison about these two materials. Can you move to the next slide, please? So the first criteria that I will compare is that durability. So compared to steel, concrete can endure very high temperatures for long periods and offers excellent protection from explosions, while steel is adversely affected by weather conditions and rusting. It may corrode when it comes into contact with water, and if left without proper care, it could affect the safety and security of the structure. The second criteria is the earthquake resistance. So the steel structure can withstand earthquake more effectively than the concrete structure, while concrete structures are brittle, so they are less earthquake resistant. And the third one is the carrying load resistance. So we all know that concrete is a composite material consisting of cement, sand, gravel, and water, right? It has a relatively high compressive strength but less tensile strength. So while the steel is extremely strong, stiff, tough, and ductile. So in comparison of the carrying load resistance, I think that steel is the winner. Can you move to the next slide, please? So these are the picture of the rusting steel because of the weather condition. So the next criteria is the self-weight. So the steel is 60% lighter than the concrete, so it will make the transportation and handling procedure easier. The fifth one is labor, because steel needs bolting and welding, so it requires more skilled labor. And the last but not least is the cost. So I make the wrong statement uh, in the PowerPoint. Actually, steel is getting more expensive because of the price of raw materials for making steel, iron, and coal are on the rise. Moreover, the steel structure requires skilled labor, so it may add up the price at the end. However, the steel structure is less expensive to build and maintain. A large cost benefit to concrete is the fact that the price remains relatively consistent, and building with concrete is also very fast. When time means money, this makes a particularly attractive option. But like in the overall, I think the steel structure is more cost effective. Can you move to the next slide, please? So this is the video about the concrete highway bridges of Highway 401 and different demolishes to see how fast the concrete highway structure bridge can be demolished.
Canada's busiest highway gets a lot of traffic. And with busy roads comes wear and tear. The overpass at Dufferin Street and the 401 in Toronto is due for a rebuild. But before a new overpass can be constructed, The old one needs to be demolished. That's where Priestley Demolition comes in. The demolition on this project has to be done in stages so that the traffic on the 401 isn't interrupted. Priestley will concentrate their initial efforts on the two eastbound collector lanes. The overpass is next to the busy Yorkdale Shopping Center, and the roads need to be reopened by 8 a.m. Before the demolition begins, Priestley gathers to have a toolbox talk, where they will go over the plan of attack one last time. It's now 10 o'clock, and the road closure has come into effect. First, the road is covered in sand to protect it from falling debris and heavy machinery. With the sand laid, Priestley is now on the clock and must make the most of their time. Hydro lines run directly beside the bridge and are a major obstacle that Priestley has to avoid. Spotters are used to make sure that the equipment is operated as safely as possible. Priestley uses hoses to keep the dust at bay and to keep good visibility for passing motorists.
So far, we're about 2.5 hours into the job. Things are going well. Now it's a cleanup effort to get us off the road and open it up again.
It's always a challenge to try and get this amount of material pulled down in one night, cleaned up, and hauled away in one night. We got to leave this place spick and span, and the team here has done a really good job.
Normally, during a bridge demolition, wreckage can be staged off to the side for later removal. But on this job, there is no room surrounding the bridge to stockpile debris, so Priestley has to make sure that all materials are offloaded by dump truck before morning. With the demolition complete, Priestley has made way for a new bridge that will serve commuters for years to come.
Actually, there is one more criteria I forgot to mention, and that is the environmental effect or eco-friendly. Concrete is primarily made from sand and stone, and once concrete or concrete block are constructed, they cannot be recycled or reused. But recently, concrete may be crushed and used in the fusion mixtures, as Hongwei said, but it just account for the small amount. Most concrete will end up in the landfills. On the other hand, nearly 100% of steel structures are made from recycled steel and can be reused well after the building lifespan. So when looking at the initial construction of equivalent bridge designs, steel reinforced concrete or concrete ones appear to have lower overall environmental effects than the steel ones. But in particular applications, however, engineering, aesthetics, or economic criteria might outweigh the environmental factor. The other one is the steel structures are easy to transport and handling, and unlike concrete structure, the steel structure doesn't need any foam work. So the two designs are competitive with numerous examples of both type in use. The traditional criteria for selecting a particular design have been engineering requirements, initial and life cycle costs, experience with and availability of a particular material or technology, aesthetics, and the ability to erect the structure under local environmental conditions like climate or topography. So whether steel or concrete, which one is better, I would let you guys decide because it's up to a lot of elements. So that's the end of our presentations, and thank you for listening.
Okay, thank you. Group 8. Does anybody have any questions? There we go, some questions for you. Okay, so let's start off with James. Roughly, what is the lifespan of steel compared to concrete bridges? Yes, very good question. Who's going to answer that? Group 8. Michael, you had talked about steel.
So
You guys should be
what is
answering,
the-
not waiting for me to call somebody, okay? So,
Sorry.
go ahead.
So for steel, as you can tell, it goes, it lasts over 100 years. And then for concrete bridges, it lasts around 130 years, or sorry, between 50 to 70 years.
I'll answer this one. So the highway bridges should be designed and maintained to last at least 70 years with minimum maintenance. And there is a report that I look into of the Dr. Parker. It's a report about the bridges in Pennsylvania, or the one states of USA. And yeah, he do a research about the concrete highway bridges and the steel highway bridges. And the result of the research is that the steel highway bridges can last averagely at about 80 years, and the concrete highway bridges can last about averagely 75 years or 70 to 75 years. Is that answering?
Thank you. So Ran is asking, do you guys know how much, which is a very good question, how much it costs to maintain a concrete first or a steel bridge, or both, the cost for maintenance?
Well, actually, we are not doing a deep research about the cost to maintain a concrete or steel bridge. So
it really depends on the type of bridge and the maintenance. Like,
yeah, but there's an average, right? That's very
I can
important.
give average. So for steel,
thank you.
It accounts for materials, labor, equipment, all that stuff, and then engineering. And this is just one example. For steel, it would cost $111,000. And for concrete, going through all those parameters, the total would cost $154,000.
So it costs more for concrete, and concrete is a shorter lifespan, and concrete. So why do we have so many concrete bridges, right? Okay. Trong. Thank you, Michael. Okay. Out of the 4 types of steel introduced in the presentation, which type of steel is the most flexible, which can be used to design arch bridges? And I think, was it Gabriel that was talking about that, or was it you,
was
Michael?
me. So steel and concrete. So materials such as cast iron can be used for arch bridges because it's very flexible.
Okay, thank you. Okay, Harshal is asking, in the first bridge demolition video, why didn't it meet the standards? Yes, what were the standards that it didn't meet? That's a very good question.
The standards was the span of the bridge.
They couldn't correct that?
It was the width. It was just too long.
Okay. So
It was it's hard to explain. It was the clearance of the entire thing.
Okay. It was just too not long, like that it wouldn't take enough. Is that what you're saying?
It was
Too
covering.
wide?
It was covering too much area for how much it weighed.
Oh, I see. Okay. Thank you. Okay, Raymond is asking, okay, for concrete bridges, through what method does chemical and moisture migrate into the core of the bridge and cause damage? What then is the best method to protect rebar contained within from chemical and humidity migration? That's a big question, Raymond.
There's so many factors that will affect to the chemical and physical to the migration. But however, the most big thing that will reduce is poor concrete practice and low quantity material that will reduce those damage. But how to protect, I guess, make better design. But the scientists still are spending time and studying in the factors that to determine better durability for concrete to meet the goal.
Yes. Thank you, Henri. Okay, Sebastian, how are the bridges foundation built in the ocean? Are you talking about like steel versus concrete, or a specific one, or what are you asking here? In general, I think we had one of our other groups discuss about how they do it in water, but in oceans, I mean, go ahead, somebody.
Well, I believe I can answer that question.
Go ahead.
Well, we don't talk generally about this in our presentation, but I know that they build piers in the ocean. They drain the water. They use steel as a reinforcement, and after that, they fill the pier with the concrete to make the base of the bridges. And after that, they just start building. Usually, it's concrete. Yeah, that's the way.
Yeah, I think we talked about it in one of the other presentations about how they do it in water, but. Okay, next is Jerwin. Okay, sorry. Jerwin is asking, you have mentioned that maintenance cost is less for steel bridges. What are the common maintenance performed to steel bridges, and how frequent are they performed in snowy places like in Ontario or Canada in general?
There are a lot of common maintenances performed for steel bridges. Some include washing and cleaning, sealing the deck joints, clearing the drainage areas, sealing the cracks, and removing trash and other debris. And I'm not sure about how frequent they're performed in snowy areas.
Okay, thank you. Okay, Daewoo is asking, extreme snow weather may influence steel bridges corrosion. Which method can be used to prevent this problem? So what can happen to the steel bridges with regards to corrosion?
Well,
to minimize it at least, or either minimize it or even prevent it, which preventing it is kind of not going to happen, but yeah.
Well, I talked about this in my presentation, and I mentioned that the atmospheric condition, the south, and all of that, of course, makes the corrosion. So the way to prevent is just to implement a barrier of paint and just keep the maintenance to keep it in well conditions. That will be the method to prevent the corrosion.
Thank you. Okay, Rayfong was asking, which type of bridge is being built in most common in, I guess, in Ontario or Canada? I think. With regards to what shape, or are you talking about type of material, or what are we talking about here, Rayfong? Steel versus concrete. Group? What's the most common type of what's the most common type of bridge that's being built in Ontario? Hello? Group 8?
Well, I would say that the most frequent type would be the beam bridges. Those are the simple structural forms for bridge spans, supported by an abutment or pier at each end, and usually those are from concrete. Those are the more frequent use.
Yeah, if you talk about steel or concrete, I would say like reinforced concrete would be the most commonly used bridge in any place.
Yeah, it helps for the long-term costs
Yeah.
and the life cycle costs.
All right. Okay, so final presentation is complete. Yes, you can, Rand. Go ahead. Okay, so this goes back to the question. So if a steel is cheaper and is more effective, do you guys know why there are a lot of concrete bridges in Canada?
Well, actually, it's based on a lot of aspects like the weather, the topography, or the climate of that areas. So, like maybe Canada have the snow or the because if the steel contacts in the water, it may rust it and corrode. So yeah, that I think it's based
We'll
on a
also
lot.
look at compression, right? You're also
Yeah,
looking at compression with bridges. It can handle compression more. Concrete can handle more compression than steel, right? Better. So that can be also taken into account with the amount of weight that would be placed on it, so that it doesn't have that any bending in it, right, or anything like that. So that could also be taken into account. But okay, but that is a good question. Maybe you ran also another thing is that to make it have the same kind of compression so that it can hold the same amount, might have to have bigger, deeper beams. That would be too much cost. It's always about cost. It always goes back to cost when it starts, not just the maintenance, but the beginning of it too. So anyway, okay, so we're gonna take a break. Okay, let's take a 10-minute break, and then we will come back. We're gonna have our work period, and I'm gonna at that time open up Teams, and then we can go ahead and if you have any questions, you can come on there. I know Michael, you had a question for me, so we'll talk about it in 10 minutes. Okay.
Okay. Do you want me to call you
Okay.
on Teams?
Well, I'm gonna open up a Teams meet over there in about 10 minutes, and then you can just join there. Okay.
Okay, thank you.
Okay. Thanks, guys. Okay, let's take a break. All right. Okay, guys, so we're back. I'm just gonna open up a Teams meet here. So if you have a question, please come online and we can discuss. Otherwise, you guys should be working on your 3D. How is that coming along? Let me know how do you, are you guys starting it now? I hope everybody's now have started it. Hello? Yes? Okay. Slowly. I know it's slow, but you have to spend more time, but eventually you'll get it. Okay. Good. Okay, excellent. Good. Okay. So let's go ahead. I've opened up Teams. Let me know if you have questions one-on-one. You can join on there and I can help you. Okay.